fine-grained image retrieval, long-tail visual recognition, and fine-grained visual understanding. And the first talk comes from the Yi-Zhe from University of Surrey. And let's welcome Yi-Zhe for his talk.
Okay, thank you, Xiushen. Yeah. So I'm sure that you guys have a lovely first session of the tutorial already. So, and for the many of you, I think this topic of fine-grained image retrieval might be a bit alien. Okay. So I'll try to give you a rather high-level picture today. And then obviously, if you want any offline discussions, just send me an email. I'm quite happy to talk further with you. So I'm from Xiushen said, University of Surrey. I lead this lab called SketchX. So we do our research related to Sketch. So let's just very quickly recap on why we do fine-grained, because this will have consequences when we actually talk about the need for retrieval. So here we have three lovely animals. Hopefully you agree with me. And then if I grab anybody like a stranger from the street and ask them, look, what those animals are, and then they'll probably tell me this is a dog, and that's a dog, and that's also a dog, right? Obviously, as you can see, those three dogs are not very happy because they are not just a dog. I mean, they have a name to it, and then they have a different species. So then if the stranger I grabbed from the street is somehow a dog lover, then she or he will tell you like, this is a husky, that's a chihuahua, and that's a bulldog. Now, all the dogs obviously is very happy, as you can see from the big smiles of the bulldog. So that's really what we do fine-grained, because fine-grained is this very inherent part of human vision system. Okay, it's the very heart of human and computer vision for that matter. So what is fine-grained? So fine-grained's been there for a long time, and I wouldn't bore you with the details here because there are already surveys and many workshops exist. So I'll just highlight a few. So this is the a very recent survey, I think, written by Xiushen and colleagues. So this is very good. It's already on archive, and then it offers quite comprehensive survey, actually on many aspects, including retrieval in the survey. And then there's also this parallel workshop in CVPR 2021, the 8th edition already, on fine-grained visual categorization. And there's also other workshops that, for example, this one, ICCV 2021, that really is not particularly on fine-grained, but it does touch on many of the other related topics to fine-grained, especially sketch-based fine-grained image retrieval. So if I give you a very, very high-level picture of what fine-grained the community is, the classification and retrieval basically are the most studied. Classification is by far the favorite child. And for many of you in this Zoom room, I presume classification, i.e. categorization, is probably the thing you've heard that's being the most associated with fine-grained. Now hopefully I'll change your stereotype on that, and then to convince you that retrieval is also a very integral part of fine-grained analysis. So, and recently there's also a bit of a move towards not only using images to retrieve images, and then or using images to perform categorization. There's also fine-grained analysis on videos, 3D, and text. Okay, and then from a technical point of view, people have been doing generation other than just categorization, and then transfer learning, and so on and so forth. So details, obviously, you can just refer to the survey. But that's not the focus of this particular 35 minutes of the tutorial. What we are interested in is actually retrieval. So now let's start by analyzing the difference between retrieval and classification. So to me, the one thing that plagues both views, and also links them, by the way, is this curse of labels. Now, if you just start looking at the this nice big figure, so when we do classification, obviously, as you know, we'll need expert labels for training, and those expert labels are very hard to obtain. Okay, for example, if you look at the So the dogs on the right, yeah, and then they each have a label, right? Now for me, that pug and chihuahua may be the only two I can recognize. And then if you ask me to label those images, for example, I'll find it really hard. I'm not really capable of doing that. And this problem then, when translated to retrieval, is even more significant, because retrieval, you need to actually start with a label, right? So for example, without knowing this label, how do I retrieve this particular dog? Yeah, so that's really hard. So the typical problem then comes down to, on the bottom, as you can see, let me bring my pointer in. Yeah, you can see at the bottom here, then comes to the scenario, then okay, I've seen a dog on the street, and then actually I want to retrieve that dog. But then the question you ask yourself, the first question is, how do I do that? How do I initiate this retrieval? And then most people just say, okay, that's probably a dog. Now, if then you're not careful, then all you retrieve are dogs, i.e., there's no fine-grained information at all. Yep, what you retrieved are basically just dogs with no fine-grained discrimination. Okay, so I've hopefully convinced you that retrieval and classification are different, and especially we know that on this label thing, on this expert knowledge thing, that angle, that those two things are fairly different. Let's then motivate a bit more on why we need retrieval, okay? Because you've not heard much about fine-grained retrieval. Why do we need it? Why don't we just stick with categorization? So let's say you move into a new house, and then your girlfriend or boyfriend decided to buy this chair that you think fits in very well, right? So this chair, you imagine as these 4 legs, and then with like arch back, and then there's 3 back pillars underneath the arch back. So let's say, look, you come up with this description. Okay, it's a 4-legged chair with arch back and 3 back pillars. Now, obviously, we're not extremely rich, so we resort to IKEA. Now let's type that sentence, that description of the chair into IKEA. Now it's 4-legged chair, arch back, 3 back pillars. Obviously, IKEA will give you 0 results, right? Because maybe they're not really particularly good at image retrieval. Let's then try to reduce the query a bit more. Let's just try 4-legged chair with arch back. Now 0 result. Okay, so that may be the point. You think, okay, maybe IKEA can do a bit better. But fair enough, maybe the chair is called differently. You see, this is the start of the problem. Maybe the chair is called something else, right? It's very subjective. It's very ambiguous. So let's try to reduce it a bit more. 4-legged chairs. Okay, 0 results. So why is that? Clearly, I think we should be convinced it's because the label you give into the chair, the label you initiate your retrieval, doesn't agree with the label in IKEA's image retrieval engine. So then obviously the end result is you just go for a chair, and then you're going to look at all the 838 chairs, and then see which one you like. Obviously you think, okay, IKEA is not great. We have Google, right? So this is me, I think 2 days ago, trying the same query with Google. Now, okay, so must give it to Google. Most chairs, so first of all, it does give you results. Second, most chairs are 4-legged, okay? But then that's probably not a surprise, because majority of the chairs have 4 legs, okay? But then it really doesn't have this arch back. It really doesn't have like 3 back pillars. What we really, really want for fine-grained image retrieval is, given this query, to have this fine-grained ranking of chairs, where you see the first ranked chair is of arch back, 4 legs, 3 back pillars. Okay? And all the other retrieve results on the first page, on the first few pages, are pretty much the same as that. But then they also have a fine-grained ranking. As you can see, the second rank result might be arch back, but maybe a few more pillars. Yeah? And then if you look at rank 5, rank 7, maybe it's not arch back anymore. If you go to rank 8, maybe okay, the 4 legs are a bit different. Okay, hopefully you get the idea now, yes? So retrieval, fine-grained retrieval, is actually very practical and very useful. So how do we do it is the problem. So let's say, okay, you're convinced that retrieval probably is worth doing. Now, what's the problems with retrieval? I go back to this cursive label thing. Now you've observed how IKEA works, how Google works. In particular, you've observed how IKEA doesn't work. What if the label you give it doesn't really match the expert knowledge that when IKEA's retrieval system was trained, okay, that system is trained to understand. So it's basically the EO pose to start with. Why? Because retrieval dictates expert knowledge. Now, to get that label of that dog, to get the label of the chair, that's going to be requiring expert knowledge. For example, the 4-legged chair with arch back and 3 back pillar. That's the example we gave yesterday, right? Is there any label for it? Or do we just need to type in this? For all I know, maybe given to an IKEA person or maybe to a furniture person, maybe there's a name for that chair. But to be honest, I tried, I couldn't find it. Okay? So it does require expert knowledge. So therefore, the problem is EO posed. Yes? So where do I start? That's the problem. So then this triggers the problem of what is the best input modality. So for retrieval, you feed in an input query, right? For categorization, you just feed in the image. Now for retrieval, you feed in an input query. So like I said, this can be the label. This can be text description. This can be a sketch. This can be another image. So let's debate on what will be the best input modality here. So let's look at the bottom here. So let's say, I want to buy this particular shoe, okay? Obviously, this is the shoe I want the retrieval engine to be able to retrieve. So find me that shoe. And then the question is this question mark. So what is best input? So obviously, if you have the image, then you can initiate retrieval. That's called content-based. Now we'll come back to that very soon. Now obviously, if you do have that, fair enough. Even image might give you this shoe and other very similar shoes. So that's great. But then the problem comes down to, remember, you don't always have the image. Because if you have the image, it somehow, so goes against the idea of why I want to do retrieval in the first place. Now, if you want to have some, very similar images, obviously that's fine, right? But then, it does pose the question of why do you need to do retrieval at the first place? And second thing, which is very, very important for fine-grained retrieval, is this idea of human subjectivity. Okay? Now, people describe things differently. People perceive things differently. The more fine-grained you go, i.e. the more detailed your description goes, the more ambiguous it gets, the more subjective it gets. So if I write a sentence, an input query for that shoe, I might come up with a boot with laces and spotted design. Now, for people in this room, most of you might not agree with me, right? So you say, okay, what are you doing with this description? And this is the whole concept. This is the whole idea. So if you're not careful, the input modality might induce lots of bias, therefore makes retrieval very hard. So let's keep that in mind when we go further into this talk. So now, so far, then the fine-grained image retrieval literature, FGIR, basically can be categorized into two categories based on input. One, like I said, is content-based, i.e. use the image as input. And the second thing is sketch-based. This is used as a sketch as input. So I'll go into both in detail after we go a bit further into the difference between content-based and sketch-based, okay? So difference of using image as input and using a sketch as input. So to me, what's important of the input, doesn't matter is a photo or a sketch or something else, right? Is you need to precisely express fine-grainedness, okay? So I need to have a way to be able to describe any detail I want the retrieval engine to focus on. Okay, I want to be able to describe the details. Can be the pose, can be some decorations, right? Can be something really subtle. So what input modality can give me that? Okay, now obviously, like I said, if the image is probably the best, but then you might not have it. And then the worst thing about the image is it's not very subjective. It's this flexibility to meet subjectivity. Okay, because the image is not flexible, right? Obviously, you might have other research, something like editing image, but then that's not that's part of this tutorial. So now, how do I then also embed flexibility into my input query? So let's compare a few modalities. So content-based, like I said, just using image. Okay. So for example, I want to retrieve this shoe. So for some reason, I have image of this shoe or maybe some very similar shoe. Okay. Now that can do a good job if you do have this similar image to hand. But then the idea is you might not. So I don't have this image to hand. What do we do? And also, it's less flexible. So what if I want to change a few things on this image? Now, what if, let's say, okay, the shoe I want have a buckle here, maybe here. Okay, what do I do with this image? Do I do Photoshop? Or do I do paint and then paint something on? But then that will actually go towards sketching, you see? And then there's also text. Now, this is probably the most widely used image retrieval query modality. So we've seen already, so text is flexible, so different people come up with different things. The more fine-grained you go though, you also have more ambiguity. So for many people, describing this shoe in a fine-grained fashion is very hard, okay, to start with. For example, open toe, wedge heel, crisscross, and so on and so forth. And then this is not my description, by the way, this is taken online. So it's hard, and it's ambiguous, okay? And like I said, sketch is another modality that's been used for fine-grained image retrieval. So it's good, it's flexible, because obviously you can sketch in different patterns, the patterns you like. You can sketch in the buckle as said, if you want, okay? So it's flexible, and then it's less ambiguous, because, it's a visual pattern, right? It doesn't really have this language barrier, okay? So it's still a visual domain, although it's a bit abstract. So, okay, so the ambiguity there is less, but then the overall problem comes down to icon sketch. So if you ask people to say, look, can you sketch this shoe? Most people will say, look, I can't sketch, okay? So now that is the problem facing sketch-based retrieval. So let's say, what's the key challenges then, okay, of fine-grained image retrieval? Obviously, because this is fine-grained, we're not interested in more than one category. So RE, we only look at one category at a time, okay? So we're not interested in, if you have shoes and chairs, we're not interested in chairs, yeah? We're just concentrating on shoes. Now, the first challenge is obviously very similar to categorization and classification. You want to have this fine-grained embedding, right? Where then similar fine-grained visual featured objects like shoes, for example, are clustered together. For example, you have this sort of like sporty-ish shoe. You have this like boots. You have like slippers, and so on and so forth. Now that's the first challenge. Now that challenge we can borrow a lot from categorization and retrieval. Categorization and classification. The second challenge for retrieval is just have this fine-grained embedding space is not enough. So given a query, you also want to build this fine-grained metric space where then you can induce a ranking that is fine-grained, okay? So in this space, you can see here, this is probably the best match, and then second best match, and so on and so forth, okay? So we want to rank all those gray arrows, all those gray arrows, so that I can produce a fine-grained ranking list. Another challenge is most commonly you have a cross-modality problem. So for example, for sketch-based image retrieval, fine-grained image retrieval, you might have to build a shared common embedding between your images and your sketches. Okay, so those are the three challenges in terms of fine-grained image retrieval. So let's start with content-based first. Now, content-based is fairly easy to understand. I mean, this is the same as any even just a content-based, not fine-grained image retrieval, it's normal content-based image retrieval. So you put a picture, it gives you a fine-grained ranking of photos and pictures. So this problem was first identified in 2015, and where then the authors proposed guidelines to construct data sets and so on and so forth, and offer a few insights on this problem. And then it wasn't until actually this particular paper in 2017, there was a major push in terms of deep learning on doing content-based fine-grained image retrieval. In this particular work, they aggregated feature maps to identify the maximally discriminated regions. As you can see, the technical difficulties there is pretty much aligned with that of categorization and classification. Obviously, there's associated problems like building that fine-grained ranking metric space. Okay, but then typically, I mean, over and above all, the technical solutions in content-based fine-grained image retrieval is pretty much aligned with that of fine-grained categorization. So here are the common data sets people use, and then as you can see, mostly they just use data sets from the recognition literature. Okay, and then there's also a field of old data sets built for retrieval that's also been benchmarked on this content-based FGIR problem. So here are just a few examples of those what data sets look like. Okay, this is the area holiday and then flowers, and those data sets on the fine-grained categorization. I'm sure you've seen a lot of yesterday already. Okay, so this is a table summarizing state of the play. Obviously, there's might be a few papers that I missed. So the common sort of like benchmark metric people use is this recall at K. Okay, and then as you can see, here is a few example papers. So from 2017 to 2020, and then you can see that the recall gets fairly good towards the K equals to 8 already. Okay, so this is more, but then this is fairly in line with the results we have in categorization anyway. But this does indicate maybe there should be better and more custom data sets for the retrieval problem. So for example, maybe we want to introduce a larger gallery so that it's going towards a more practical setting. Okay, so that is a very quick overview of content-based FGIR. Now, going towards sketch-based, I want to actually first compare and contrast them at a high level. So I think by now you should have learned that for content-based FGIR, you have this problem of the unavailability of the exemplar content, i.e. the corollary. So for example, I want to search for this shoe, right? I just don't have it. I don't have the image. So if you don't have it, then obviously another option is to be able to actually render it. Now you can do it in Photoshop, you can do it in Paint, or use your Apple Pencil, I don't know. Okay, but then it's going to be quite hard to faithfully render for many people. So that's somehow the the bottleneck of content-based FGIR. Now coming to sketch-based, then you don't have this problem of exemplar content anymore, because the sketch is produced of you. So you have a mental picture of the sketch of the object, and then you sketch it down. So basically, as soon as you have a mental image and some sketching skill, then you're fine. Also, sketching comes naturally to human, right? A sketch speaks for 100 words. It's the same as a picture speaks for 1,000 words. Okay, so let's motivate a bit more on sketch for retrieval. So sketch as an input modality, a domain for retrieval. Now on the left, you have a sketch for this photo on the right. So first thing to realize is the sketch is not a pixel-to-pixel mapping to the photo. I.e., if you align this sketch on top of the photo, you wouldn't see very good alignment. But some of the important patterns, like the buckle, for example, here, like the cross strap here, for example, they are reflected very well. Okay, and then you can see the shoe, the heel, is also reflected fairly well. Okay, now if we use text as a median to help us to understand this problem. As you can see, for text, we also have sometimes indications like what the features are. For example, the cross strap here in the red box. But look, cross straps might have different patterns. So by saying a cross strap is not an as fine-grained description to this particular sketch. Now, so on and so forth with the heel, right? So here I said, okay, 9 centimeter heel. Now, hopefully in computer vision someday we can do, as a fine-grained metric space that can understand, empirical measurements, but really we can't, right? But then you see this sketch already offers you a fairly good indication of how high the heel should be. But there are also cases where then text give you things that sketch don't. For example, leather, the material, yes, of the shoe, and also color. Obviously, sketch don't have color. So some pros and cons. But the overall message here is sketch does give you a very fine-grained, representation as an input modality. So the physics challenges, like I said, is cross-model, okay? And then is this a human subjective problem? And also a very salient problem that's plaguing the community is this problem of learning under small data. Now sketch, as I said, most people said they can't sketch, right? So similarly, that problem extends to data collection. So to get a very large sketch data set, that's basically quite hard. That's why common data sets are fairly small. So here is a very quick demo of a system we built at SketchX. As you can see, people can just sketch a very rough shoe, and you can see here, look, right? So 3 buttons, and then if you actually browse a bit further, then you see shoes getting less similar, and to the end, you see actually it's very different. So here is a very, very high level categorization of the development of fine-grained SBIR, so fine-grained sketch-based image retrieval. In the beginning, when the problem first introduced, they just want to differentiate on pose, okay? And then it wasn't until actually 2015-16 with a few new data sets from James Hayes, Sketchy, from Queen Mary, then, and also with the popularity of deep learning, people start to look at very fine-grained instance-level correspondences a bit more. And it comes to 2020, 2021, people are actually going towards practicality, i.e., how do I address the people can't sketch problem? How do I address the style problem, i.e., people sketch differently? And then very, very, very recently, people tend to do this in a VR setting. So that's what I call fine-grained SBIR 4.0. Obviously, the sketch here is not 2D anymore. It's actually 3D. So here is more fine-grained. Let's not abuse the word fine-grained. This is more detailed roadmap. So 2004, the problem first introduced. And then, the beginning, people tend to focus on a bit of more engineering, technical sort of set of the problem. And then they use simple things like triplet ranking network. And then people realize, okay, so there's lots of specific things we need to do on sketches. Some people actually be doing this spatial attention thing between sketch and photo. People have been doing combining generative models and also retrieval model into one. And also people have been studying the 3 modality problem where then you have a sketch and text and photo. And then that trend continues, okay? And then people then also started to looking at different modalities. So scene sketches, people look at graphical user interfaces, people look at, like I said, 3D VR and then 3D shapes. And then 2021-ish, this is 2 CVPR papers that I think both address the problem of practicality, okay? So this one basically says, look, if you don't have enough sketches, can we actually synthesize them and then use them for training? And here you say, look, if people sketch very differently, what do we do? So this is the common baseline CVPR 16 oral paper. is very simple, basically CMS ranking network as the first deep learning problem, deep learning solution to the problem. They also introduced the first data set, but very small. So CMS basically, give you this common embedding space, and triplet ranking give you this fine-grained ranking space. And then this work in ICCV 2017 tells you like, look, attention also works very well between photos and sketches. And this is regardless of how, like I say, can this shoe and then that sketch, they might be like very different, but obviously, semantically they're the same. So attention also works here. So that's a take-home message there. And then this is very interesting work in CVPR 2020. So this is saying again addressing some part of the scarcity problem, data scarcity problem. How do we use jigsaw puzzles in a very clever way to solve this learning a common embedding space problem? So what they do is they split the image and also the corresponding sketch into different 9 patches, and then you mixed image patches and then sketch patches into one puzzle. Now the idea is once you solve this cross-domain puzzle, you already learned this very fine-grained local level alignment, which then in turn give you a fine-grained embedding that helps retrieval, for example. And then there's interesting findings here. So if your problem is less fine-grained, so if you look at a coarse-grained problem, then this doesn't work very well, which is actually very interesting. Okay, I think it's really because the fine-grained alignments is learning at patch level is really not compatible with like a coarse level problem. And then they also find out that this problem is actually once the jigsaw puzzle is solved, then it's actually not category specific, so it's category agnostic, which is very interesting. But then it's probably understandable, right? If my 4-year-old daughter can solve a puzzle of a dinosaur problem, I'm sure she can solve a puzzle of a cat and dog problem, right? So, like I said, towards the 2020 era, so people be doing practicality. So in this work, what they did is instead of asking people to sketch the whole thing first and then retrieve, they studied this on the fly setting, where then they retrieve as they sketch. Now the idea is you don't have to sketch the whole thing. You can stop here, and they already give you a very good retrieval result. So I think I'm not going to into the technical details, but basically they borrow this reinforcement learning paradigm, and they have this reward design that basically encourages early retrieval. Okay, so which are as you sketch, obviously the ranking list changes. Okay, so every time where then the ground truth rank changes a lot, that's better than we want to encourage. Okay, and then that's encouragement is actually embedded into their reward design. They also have this global guard in terms of complete episode optimization. So in most cases, they can actually retrieve using 30% less strokes. So that really helps, right? That means you don't have to spend too much effort on producing the core. Like I said, the core for fine-grained image retrieval is the most important. And then people start doing style agnostic, 2021 again, I think CVPR this year. So the question is, okay, how many photos are there? If I ask you, if you look at the sketches, you might be thinking, okay, 6. Now, apparently, it's just 2, right? You can see people sketch very differently for a given photo. Now, this particular work basically says, look, they've done some work, initial analysis on this. So basically, if you input those 3 sketches, if you're not careful, give you 3 different shoes. And then with their model, they can just basically use those 3 sketches, retrieve you the same shoe. So again, I'm not going to bore you with the details, and then if you want, you can actually listen to the author's talks yourself. Okay, so basically they rely on this style invariant and the style specific disentanglement. Obviously, the invariant part is basically where then the shared part. So it doesn't matter how different your style is, then you still have some invariance in there, and that's basically what they're trying to explore. So, and then the last work I want to talk about is this semi-supervised approach, which is very interesting, right? I think gives you very good results. Is how we can actually generate sketches and use those pseudo sketches to help you to train a semi-supervised fine-grained SBR framework. So what they do is they leverage on this photo to sketch generation model, as you can see, and this generation model can give you from a photo to a sketch, but then actually in a drawing fashion, i.e. the sketch is synthesized stroke by stroke. So here is the detailed, a bit more detailed sort of look into their framework. So they have this, generation model. Like I said, they have the 2D attention. The 2D attention basically helps you to figure out where to place the next stroke. And then once you have this reference, this vector stroke in this coordinate format, you then have to go via a rasterization process, give you a pixel map, and that pixel map is fed into the retrieval model. You have discriminator to tell you how much I can rely on this generated sketch because it might not be very good. You have this fixed weight pre-trained fine-grained SBR model that basically give you a global signal, again guarding against the training of this fine-grained SBR model. Okay, and after that's trained, the reward from the discriminator, also from the fine-grained SBR model, gets fed back to the generation, and it just goes on and on. Here is the summary of the state of play. So the metric people use is a bit different than content-based fine-grained image retrieval. So they mostly use accuracy at K. As you can see, the work here is, it's been going for many years and it's still going quite strong. So people started with working on small data sets, and relatively lately people started to abandon those data sets and work on more sophisticated and large-scale data sets. As you can see, top 1 performance is still not great, but then it's encouraging to see top 10 performance is getting there. Okay, so I think I'm a bit over time, but then I'll just wrap up very quickly. So classification and retrieval, they're different things, but they help each other. So classification to retrieval, like I said, is a bit obvious, right? So learning that metric space is something retrieval borrowed a lot from classification. Now, how can retrieval fit back to classification then? So I think there might be some interesting work on the use of web data, for example. So how can we use maybe sketches or maybe example photos to get better informed web data to help the training of classification models? Or you can maybe have this latent subclass discovery, where then you can use sketches like those found in books and so on and so forth to give you more subclasses. So my last slide. So fine-grained is important, as probably the reason why I attended this tutorial. And classification is a bit bottlenecked, and then obviously there'd be more technical solutions. But then the idea is maybe we need a better, larger data set there. And then retrieval needs more work. It has unique challenges, and then I can see it's fairly practical, and then it can help classification. Now then, there's also this, I think rather big push nowadays to go beyond 2D images into 3D, into videos, into other modalities. So I'll finish my talk with this happy dog. Okay, thank you very much.